So actually, just page down, page up. Okay. So I was asked to give a talk about HiPEAC, and actually the original was HiPEAC and Artemis in collaboration, and actually it wasn't clear to me what you like to hear about the HiPEAC organization or about the vision document that we put together and so on. So I did something that combined both the HiPEAC organization and some of the technical work, and just let me know what you like me to focus at. So, short introduction. I'm a professor at the Technion and working on computer architecture. My experience is mostly on the industry and the academia. I worked for Intel for many years, Microsoft for a few years, and right now I'm focusing on HPC, GPU architectures and operating system, etc. I'm here because I'm part of a HiPEAC advisory board, and I'm doing a few other things related to HiPEAC. So I'll talk about HiPEAC, and at the end I'll speak about some few events and activities that we are recently doing that may be of your interest. So actually HiPEAC, right now we are in HiPEAC 3. HiPEAC 1 was established in 2006 by Professor Mateo Valero from the Barcelona supercomputer system, and the vision was to try to align forces in Europe and to try to have some collaborative work among all the parties and so on. And part of the challenge was to give the commissioner some 10+ year horizon, etc. And whenever recently we have another meeting with Panos and one of the commissioners, and he asked also, what is your vision for the next 10-15 years? And I think that I gave him an answer that I'm not sure that he liked. Usually when people ask me, what is your vision for the next 15 years? So I say, okay, let's look back 15 years back and try to predict what would be your answer there. So just to remind you, 15 years back, Google was 1 year. They just established Google. And actually even 10 years back, we didn't have a Facebook. I remember 2002 or 2003, I worked at Intel on low power computers, and the first question was, who cares about low power? And the second question, we actually did things that at Intel were considered to be really radical, and when we approached the big managers of the company, they told us, yeah, you can do whatever you like, because who cares about this segment that's called laptop computers? It's only 1% or 2% of the markets. So you can do whatever you like. It will not have any serious impact on the company. Later on, about 5 years or 4 years later, 75% of what Intel produced was based on our design because the market changed so fast. So when people ask us to predict 15 years from now, my really answer is that we cannot really predict anything. We can just try to do the best that we understand and hope that we are predicting to the right direction. But anyhow, this was the vision of HiPEAC. And again, the HiPEAC was supposed to focus mainly on Europe, and you will see that we are looking on the things that we believe that Europe has some benefit or strengths. By the way, Israel, if you know geography, is not in Europe, but from the European Commission, we are part of the European Union. We are not a full member, but we are part of the scientific community in Europe, and we pay the dues, and we are allowed to participate in the project. So in that sense, at least, we are European. So what is HiPEAC in general, HiPEAC is not a project, it's a network of excellence. And there's a big difference between network of excellence and project, because we are not working on any specific project, but we try to create an environment that people can share information and work together. So this was the vision of HiPEAC 1. We start working, then in HiPEAC 2, actually we defined the very specific working packages, and we talk about mobility that has nothing to do with mobile devices. It's mobility of people and research project, and I'll extend them very fast a little bit about each one of these activities. So the mobility include internship, collaboration, mini sabbatical, etc. The main idea was allow researchers and students and so on to collaborate with each other. Research, we defined these areas of research, and we were focusing at low power education and training, which is another very important task force, application, reliability, and availability. So we established all this team. Again, if you want later on, we can extend it, and we actually created all these research collaboration teams. Again, many of the EU projects later on came out of these task forces that people work together. So we are not getting money for actually for any of these activities, just for small money for travel and so on. But the collaboration that we did in this area actually yielded a lot of projects later on. There are things that appears here and later on are less important. They're not less important, but less focused, like binary translation, virtualization. Virtualization, again, is very important, but in a different sense. A binary translation right now, people less work on it, at least in our group, for a certain reason. There are many other activities that we are still doing right now. And again, the idea was to try to create ways to spread the access, what they call it, many newsletters and conferences, summer school, etc. And HiPEAC 2 and 3 is managed actually by Koen from Belgium. So so he replaced Matteo Valero, and he managed the operation right now. So HiPEAC 3 is what we have right now, and we have many partners from the industry and from the academia. And the target for HiPEAC 3, actually I'm not going to read everything or go through everything, but the main target was to extend the collaboration between the industry and the academia, to extend the number of members. And the other important task of HiPEAC 3 was to create this vision documents, and actually we create two documents so far. I'll extend it in a minute. Okay, so again, these are the main activities, and I'm not going to cover all of them, unless if you like, I have slides, but I will not. Otherwise, I will not cover all these activities. It is very important to increase the number of memberships and so on. And many of the activities like the conferences and so on become to be international. Last HiPEAC conference, we had more than 500 participants from all over the world. And it is start to be quite attractive these days. Again, number of memberships, and I'll skip all this stuff. I want to focus more about the roadmap and these activities. So, actually, Mark that used to work in NXP right now is not there anymore. He managed this activity. Oh, sorry, page up, where is the cursor? No, doesn't like to. Okay, we created actually the don't know why it doesn't. No, it doesn't go to. I have here the document itself. If you like, I can give it to you, the vision document. And this is you can find it in this address. Actually, in this address, you can find the two documents. One was the vision in 2010 and 11, and the current one, and we are still working to update it. So just to summarize some of the roadmap items. So the document is mainly focused on Europe, which means that the document try to identify what the European, or let's be more careful, what this group of people in Europe actually think that what are the strengths in Europe, and try to emphasize it. So this is not the roadmap document of the entire computer systems worldwide, but again try to advise the commissioner what we think that he should focus at. So the main focus area, as they define, are embedded system, mobile system, data center computer, energy efficient system, complexity and dependabilities. We are missing many other things like security and few other things, and this is not a complete list, of course, but this is what are the main topics that the document is covered. And there are few interesting conclusions and suggestions. Niraj already described the global, the Internet of Things, and which is the global integration of devices. And again, the idea is to emphasize on optimization of storage, communication, processes, etc. But there's something which is not emphasized in this document, and I'm jumping from the document to my personal perspective. The document looks on all these issues from my point of view in much more conservative way, in the sense that they are talking, for example, about big data, but then they are not mentioning that actually big data implies to have a totally different way of thinking, to look on everything from the statistical point of view and not from deterministic algorithms and so on. Which actually, if we look on education task force, which is something else that I'm doing in different forms in Europe, I think that we need to start teaching more and more statistical algorithms and so on, and to move from the traditional way of discrete mathematics and so on, which is extremely important, but it is not enough. So in this document, it is not emphasized the move and the shift that we have from the ability actually to understand everything. Yesterday I had a discussion with Niraj about checkpointing of big data and things like that. This is something that not really exists if you're talking about statistical models. If you have stream of infinite data, you cannot checkpoint it, you cannot understand it, you cannot actually observe everything. It changed the way that we think, and in some sense it resembled me the discussion that was in physics between the ability to understand the equations and to go to statistical models of the atoms and so on. And but we need to switch minds and to look at all the problems that we're familiar with from a totally different point of view. So again, intelligence system and personal services, people address all these issues, but in the document you will find a lot of details about what the group think and how, what is the future, how to handle it, etc. I'll be glad to, I have the document here, but you can grab it yourself. So what other activities that we are doing in HiPEAC? So we have the conference itself, and that, as I said, it started to be quite popular. We actually align with some journal that the papers in the journal, at least some of them, can be published in the journal, which make it much more popular for the academia, at least. It gives more credit to the people. And the last meeting was in Paris. Next one, no, actually, last meeting was, it is not updated. Last meeting was in Berlin last month. Something else that we are doing quite often is to have a computing system day weeks, which is, again, we have something like task forces, and we have meetings in all these topics, and members can suggest new topics, and this is entire week that something like 1,000 people are attending with all the different workshops and so on, very intensive. And these are the list of the issues that we are covering. Again, all the issues of reliability and so on is very, very important these days. And if in the past we spoke about reliability in general or in the processors themselves, right now we are facing reliability issues in data centers and in the chip itself. So we try to address all these issues. And as you can see, there is a nice mix of academia and industry in Europe. And when we say, for example, IBM, actually it means IBM Israel in this case, or IBM Zurich. It's IBM Europe. It's not, or Intel. So it is usually either Intel Barcelona or Intel Israel, or one of the sites. But all these companies are focused on the activity in Europe, and not just the activity of the company worldwide. And of course, ARM is very strong. And we have the information, something which is very, very important for us is the summer school. The summer school is, there are few summer schools in Europe, but this summer school, this is a week which is recognized by most of the universities as a course, a short course in the university, and very, very popular. And for a week, we try to cover many of the topics. This is a short list of, just a minute, I have a short list of the activities that they have. No, sorry, this is the wrong slide. Every year we just choose something like 8 topics and try to focus on these topics. And the advantage, of course, is not just to educate the people, but this is a great meeting point between students, mainly PhD students, that spend together the entire week, and later on they collaborate on related issues. Okay, I'll try to make it quite short, and so if you have more questions, please ask. There are some events that may interest you, and here I just put 2 of them. The first is the ISCA, the main computer architecture conference. This year is in Israel, and I am the general manager of the conference. And we decided, actually, as part of the conference, or actually a day before the conference, as part of the workshop, to have the whole day discussion about the roadmap of computer architecture. And we divide the activity into 2 parts. The first part will be general purpose, and the second part will be device and embedded systems. In the first part, HiPEAC will present this document, and people, Mark Hill from Wisconsin actually has another document that he prepared with about 20 other professors in US and sent it to the NSF. He present his roadmap. And if you want to present your roadmap, you're welcome to join there. And we expect people from the industry. We expect people from Confirm, people from IBM right now, from Qualcomm, from ARM, and we hope to get somebody from Google. Also, Intel will be there, a few other companies as well. Again, this is going to be the entire day about roadmaps from different places. We try to bring somebody from China as well, and to make it as international as possible, because we believe that right now, from the computer architecture, we are in a kind of turning point, because it is very clear that we cannot continue in the same way. At least many people think that we cannot continue in the same way that we used to work. And there are many, many different proposals. For example, there are proposals that try to build very efficient computer architectures or very efficient systems that will give up some of the accuracy of the computations. Is it the right way to go? I'm not sure, but this is something that people strongly believe in. So we want to discuss if it is the right way. We know that at least in certain algorithms, we can reduce the power even in 1 or 2 orders of magnitude if we give up some of the accuracy of the results. A good example is in multimedia. In multimedia, we can get, on average, we can get something like 90% accuracy of managing pictures, and do it with algorithm that requires an order of magnitude, maybe 2 orders of magnitude, less than the traditional computer architectures. So this is an open discussion. Heterogeneous system. Heterogeneous system is a term that everybody is using it, unfortunately, in very, very different content. But for example, accelerators, which is a kind of heterogeneous system. Are we going to build future system based on accelerators? Most likely, yes. The question again is not just hardware. We know how to build it, software, reliability, etc. How we guarantee they see how we write a program to such system and so on. So we reach a point in the computer architecture that we think that we know, or at least we can analyze a lot of alternatives, and the question is what alternatives are valid and what alternatives are not valid, either because they are too complicated, or maybe the accuracy is not enough, or there are other risks like a security risk or whatsoever. So what are the right direction? Because there are few very interesting new directions that we can pursue, but the question is we want to discuss what is valid and what not. Just to go back to the accuracy issue, because I think that it is one of the most interesting ideas. The question is, can we bound the error? Because if we can bound the error, we can go back to the people and ask them, do you will to suffer 2% accuracy loss for that much data, power saving? So in many sense, we are doing it unintentionally even today. Go back to big data. If we are going to statistical models, so we are losing accuracy. We cannot assume that we are doing with statistical model without losing the accuracy. So the question is, why it is allowed to lose data by using statistical models and just taking sampling, and it is not allowed to do it when I'm doing the computation of a single point, why I insist to do it as accurate as possible and to lose an order of magnitude of power. Maybe if I shift my mind and say, okay, I need to go to statistical model, so maybe I should do it all the way and even give away some of the accuracy all the way. Maybe some other trade-offs such as reliability. Google did a lot of money by choosing intentionally to use inexpensive and inexpensive devices. So, okay, I can guarantee the reliability of the system by a software layer, and I can use a very inexpensive hardware. This is something that they are doing all the time. I can tell you, in Intel, at some point, we didn't do it intentionally, but we found out that we can use the CRC mechanism in order to recover from errors. And at one point, we didn't have any way to avoid errors coming from the memory because of buses. It doesn't matter why. And then we realized, but we have this CRC mechanism that actually the error correction code, we can use it. So there are many, many interesting trade-offs that we can make when we look on system-wide. And this may be a breakthrough in building a future systems, just to look out of the box and say, okay, let's see what I try to achieve, what are the means, how to do it. So this is part of the discussion that we want to have. The other activity is that it is a very, very early stages, but we decided the SIG-ARC is the special interest group of our computer architecture, that which is a worldwide. We decided to try to establish SIG-ARC and most likely later on SIG-PLAN for programming languages, which will focus on Europe. And the main reason is that in this case we can focus on also education, we can focus on local activities and so on. Saying so that it is a SIG-ARC Europe, one of the goals is to try to find collaboration with India and China and other places if they choose to go to the same structure and to keep to establish local chapters of SIG to focus on the local interest. And we think that it will be a very fascinating opportunity to have something like an umbrella of organization that each one will focus on the local problems and the local needs, and then we'll collaborate among us. So this is the idea. By the way, the other reason to establish this SIG-ARC Europe is that we feel that the computer architecture community should start dealing with system issues and not just hardware or architecture issues. At some point, you cannot distinguish between hardware, software, and so on. And we believe that we need to look on, actually it will be a SIG system and not SIG-ARC anymore, and to look on a system as a system and not software or hardware component, but to try to make events which will be more unified to the area. Okay, questions? No. This is because it was 2 a.m. Yeah, so maybe at 2 p.m. it was decay, but sorry. I can't hear you. What that question? Actually, as I said, in all the European programs Israel participate in this program, we have, again, this is not the topic of the talk, but we have a lot of programs which are encouraged by the Israeli government, and we have a lot of, not a lot, we have some money that came from the government for
international program.
Yeah. Some of these programs are, I think that there is even a bilateral or binational agreement with India for a research. But this is something that we are really looking for to expand. Specifically in the Technion, we try to have programs for student exchange all over the world. And yes, we try to have international programs with India, of course, and collaboration. Some of the activity, like in HPC, for example, there's a program right now that I'm a member of that we try to build high-performance computing for specific areas. And in this case, we are talking about the wafer testing equipment that if you want to do it by images or by measurements and not in the traditional way, so actually you really need to build a supercomputer or a small supercomputer to analyze all the possibilities and so on. So we have a special project to build such a system and to look on all the different alternatives for managing a fab like that. But if you look at it, what it really requires is very similar to what you need in hospital or what you need in medical devices, etc.